Let's have a closer look at super and have a look at some of the problems that can arise. Here we got class B with I and a method M in it, and class A extends B and out extends A. So out has therefore got I and M in it, effectively inherited through this chain there. And in1 also extends A, so it's also going to have an I and an M inherited, and just for good measure it's redefined inside in1 as well. And class in2 here has this little test method in it. And now if you look at this, in1.super m, okay, now that's going to go to in1 and go to extract the super class version of m, which is going to be this one up in A, effective B. And this auto increments in1.super I, so it'll increment again that one in class B has been inherited. And we've got out.this.I plus equals in1.super I. So we've got out.this.I, and in this case I is going to refer to that one there in it comes from class B through the fact that it's inherited into out, and in1.super I is again going to be in the class B, of course not the same instance naturally, well not necessarily the same instance. It comes through the it's inherited into in1 here. Right, now that looks fairly straightforward. There's a couple of points to make. Now if nothing hides or overrides I or M, that's in here, so if that wasn't there, then m.super is not actually necessary, and you could use this instead. So you could say in1.this.m, and that would get it as well because it's inherited. Also, in fact, in1.this could be dropped as well, so you could just say m by itself, because there is no m in in2, so it would go to the next enclosing version and extract the m from there, which would be inherited. Now this can get rather subtle, because now the overriding of m can occur because the only thing that's required is that this $1 that's in 2 has got to refer to something of type in1. So it could in fact be a subtype of in1, and that subtype may in fact override m, in which case it's going to make a difference whether you do super m or just m by itself. Now it can get even more complicated, and it can produce results which are not quite what you think initially. Because if we got the setup that we got here, within one containing a version of m, and when we actually instantiate the thing, we instantiate with a class which is a subclass of in1 that also happens to override m, and it turns out that just writing m by itself, of course, is going to get that version that's in the subclass of in1, and if you type super m, however, it's not going to get that version, it's going to get this version up in B. And the reason for that is the way that this handling of super works, which brings me on to the discussion of how that's actually done. Now, what you've got to remember is that once the class structure has been flattened, this has all been unpacked, and you've got dollars inserted all over the place in the class names, then you get a problem. The problem becomes that you can only use super to access fields within your own class hierarchy and not some other class. And of course the answer to that problem, of course, is you put access methods in, and you put them into the class where you want the super to be done. Now these methods are always static, and you want them to be static because you don't want them to be overridable. Now because they're static, it means you can't use super in them. Well, that's not a problem in the case of field accesses, because super, if you recall, when it comes to accessing fields, is just equivalent to doing an appropriate cast on the reference before selecting field. So that isn't really a problem. And if the method being called is static, that's not a problem either, because again you can just access it directly. But for instance method calls, however, there's no way around it, and super dot method has got to be, well, I put faked here, but that's not really the right term. What I mean is it's got to be virtualized, I suppose. I mean something like that. It's got to be done by a different method, different technique, which I'll come to how that's actually done.